Well, hi, good morning. Thanks so much for joining me here in my shop for what will hopefully be just a couple of days on this radio while I'm actually waiting for tubes to be delivered for another project I'm in the middle of. So I think over the next couple of days I should be able to restore this radio. That's a little odd. What's it doing there in the middle of nowhere? That's where it goes. So what do we got here? That would be the antenna. I think we have some instructions written right on the back. A power plug. Very odd. I don't see that kind of thing in radios very much. We need to plug something in there to make it go. Or I'm going to run a cord right out of the radio when I'm done. There's no back on this radio. This is what's sitting here for an antenna. Gotta wonder if there wasn't a back with an antenna on it, a loop antenna. That's long gone, and this is an addition. This looks pretty old. So let's just read these instructions here. IF transformer alignment 1 and 2. Number 1, apply 455 kilocycle signal to the grid of IF amplifier tube 12 SK7. Adjust second IF transformer. Okay, that's standard stuff. Apply same signal to the grid of the converter tube 12 SA7 and adjust first IF transformer. But do not repeat second IF transformer. That's a little odd. Geez, in lots of cases I just send the signal in like in step 2 here, or even straight in the antenna, the 455 kilohertz, and I do both. Wait a minute, look at these. Look at these. They look like they're from two different eras. These are the IF cans, and normally they look pretty identical. This one's got screws on the top. This one looks like it's got a slug. Just judging by that, it's had to be done from underneath also. That's very odd. So is this a replacement for an earlier one? Got a bit of a bracket here. That's unusual. Nothing else looks too unusual. 1, 2, 3, 4, 5 tubes. No visible transformer in here. Let's just see what one of these tubes is. So it's a 12 SA7. Well, it said it here, didn't it? So 12, you gotta guess that this is all the tube heaters are in series in this radio. It's a hot chassis radio, potentially. Okay, just a couple of screws here, and out it'll come. Look at the knobs on the front. It'll have to come off. Okay, glass is in good shape. Grill cloth's looking a little dirty, but not too bad. Not stained or anything. Now these knobs, these are not the knobs you'd expect on something like this. Not at all. At least not what I would expect. Let's see if we can get them off here. Okay, the tuning knob moves the pointer. A little tiny screwdriver. Just a little bit bigger than that. That's a bit of a challenge here. Get a little more grip with this. just really, really tight. Yeah, I'm sure these are not the original knobs. They're probably brown knobs would go on here. The screw type, this is probably just a slide-on knob arrangement. What's up there, Shadow? Maybe she thinks some food's going to come out of this. Maybe a mouse or something like that. These are two different screws, machine screws, machine type screws. Screwing into the, what I'm sure is big light cabinet. You be very careful with these screws. People often replace these with wood screws. And the wood screws, they have a wedging action as you screw them in. And this stuff is no good in tension. That's going to crack. But not in this one. Not yet. Also, nope, there's more holding it in here. 2 more screws. So you put these screws in, not too tight. Do not get carried away. I think that's a brass screw. Yeah, that's a brass screw. This one looks different. This looks like a steel screw. So I am not the first one in here, that's for sure. So far we've taken out 4 screws and they're all different. The speaker is not coming out with it. Isn't that an annoyance? I'm looking at the speaker wires run right down in there. They're caught here. If I uncatch them, I think we can get the chassis out. A lot of radios are made so chassis comes out, speaker stays in, and there's enough wire to do this kind of thing here, which is what I've done. Okay. Nothing unusual going on here. Pretty old capacitor there, so let's see if they've done some capacitor work under here. Tough to tip this guy up. Let's do it like this. Well, it's full of old capacitors. Now this looks like a replacement here. Yeah, for sure. This has been replaced. And even that might be a replacement. Pretty large capacitors here. That's the first thing to be suspicious of course, on an old radio like this. Turning this radio on in the condition it's in. Well, offhand I don't see any reason not to. I wouldn't plug this straight into the wall. Plug this through my dim bulb system, of course. I think it's worth doing. Now, what about this speaker? Should I disconnect those wires? Probably on my way to replacing all these capacitors here. Probably this one too. I don't think I want to do it with these restricted wires here. So now this is a permanent magnet speaker up there, just 2 wires going to it, straight to the voice coil. I'm going to be a little lazy and just cut them off rather than try to desolder them. set this aside. Looks like some kind of adjustment here. Yeah, there's a capacitor there. This is actually the holding it in place. This is the adjustment here. Now, that other IF coil, if it was intended for this radio, then there'll be a clearance to get at it past all these components. I mean, not this one. This is pretty crumbly down here. It's just hanging from the wire, but yeah, I can get him right in at it between the what I'm assuming are original components. So I guess that's original. The big guy and the small guy. Does that somehow relate to the special instructions on the back? Okay, so I'm looking at the capacitors just to see if anything looks really bad. And they don't actually look terribly bad. It's got two molded ones up here. Why the molded ones? Somebody did this. While they were here doing this, they could have done this and these two. Don't think so though. Guessing they're original. Okay, power comes in here and here. Okay, this wire is making it over to the switch. This other wire, I'm not going to be able to see it. Looks like it comes all the way down onto this tube, which is probably the rectifier tube. Yep. Well, I really like trying to operate these things before doing anything with them. Generally, I can do it in a fairly low-risk manner. Don't eat the antenna, cat. So if this is the first of my videos you've watched, I do have methods of powering up stuff like this that are low risk. I use a dim bulb system. I also have this variable power supply here. I have an isolation transformer beyond this. Or before this, there's an isolation transformer, then this. So this outlet is isolated, but nothing else in my shop is. Everything else is either three-prong plugs on it, like this bigger equipment, like this guy here, or I've run a ground bus. You can see this green wire here, running around picking up the cabinets for the equipment that is two-prong unpolarized, older equipment. And most of this has been restored or worked on, so it's a low risk of a short to the cabinet of any of these pieces of equipment. I'm just letting you know that it's not just willy-nilly plug it in and see what's going on. There's some thought behind that. So that's the on-off switch. We need to hook up a speaker. We need to hook up a speaker. Okay, we'll pick a speaker. These are leads going to a speaker in my shop. It's mounted up on the wall. It's a small speaker. Okay. Take some bets. what do you think is going to happen? So, okay, so I'd put 25 cents, it's going to hum. When I put 50 cents, it's actually going to work. And I'll put 25 cents, that's a whole buck, that it doesn't work at all. That's my that's the way I would look at this. Switch is off. First, we want to make sure off is off. I'm going to be applying power through the dim bulbs. The lights are there, just behind shadow, and nothing should happen. We should see full voltage here. 113. Seems a little low. Light didn't come on. Nothing happened over here. Why so low? Because it's running through the dim bulbs. They're like resistors, of course, and so you're pulling power through a resistor. Well, if you pull power or current through a resistor, you get a voltage drop. So, but nothing being pulled through here. It's just low today. Today it's low. It's a low day for voltage. Maybe the wheels aren't turning as fast at Niagara Falls as they normally do. Okay, now we're going to turn the power off. Turn the switch on. Turn on this radio is going to come on to some degree. These lights should come on. They should come on dull, be bright at first, dull down, and then come up a little bit depending upon how much power this draws. It's a small radio. I'm just going to reduce this to one light, one small light. That's this one over here. Okay, here we go. So the lights come on, that's good. Didn't see this bulb react at all. That suggests no current flowing in the heaters of these tubes. Tubes are in series. Any one has an open filament. None of them work. And Shadow is studying them very carefully there. And I'm pretty sure we've got a open heater tube in here. Another thing that's possible for me, I just turned this guy on. I didn't really check to see if those are the right tubes or in the right sockets or anything, because from time to time I get a radio. Somebody's taken it upon themselves to do something with the tubes. They pulled them out, they stuck them back in, all in the wrong sockets. Could that be the case here? Well, it could be. Okay, that's how far we got. Not very far. Okay, which one of you guys is all messed up? So here's the rectifier tube right here. Definitely. It should be like a 35 something or other or something like that. This is going to be challenging here. It's on the top, I think. It's a 35Z5. Is this the rectifier position? I guess I could dig up maybe I should dig up the schematic, or I'll be doing a lot of guesswork. Yeah, pretty sure that this would be the rectifier tube. Got this guy right near it. It's got this big resistor here. Yeah, it all says rectifier tube. I think I'd better get the schematic, and we'll do it that way. Otherwise, I'm guessing. Now, what radio is this? This is a what? Well, this may be a problem. Right here. Well, what radio is it? It's a DeForest. Looks like there was once a sticker on the bottom, which is gone. That would have given us everything. There's nothing inside. Uh-oh. Uh-oh. There's no hint here. It doesn't have a hint. Not a hint. Okay, I'm going to do some research. What I'll do is I'll go on Radio Museum and I'll call up DeForest radios, and then I'll look at the images and see if I can match an image against this radio. See if we can nail it down that way. Right, Shadow? Well, this was really easy to find on Radio Museum. I did exactly what I said I would do. I flipped it into photo mode. There are hundreds of DeForest radios, I kind of took a guess on the age of the radio, and the first image that came up was for this radio. So what could have been really difficult turned out to be really easy. We got a fantastic schematic here with everything on one page, and my radio is one of these DeForest, I don't know which one it is, but maybe the difference is very minor here, I don't know. So the first thing we're interested in is the tubes. They're listed in a couple of different ways, but here they are listed by location. So yeah, 35Z5, we pulled that out. The next tube over is a 12SA7. I'm just taking a look here to see what it is. 12SA7. Okay, next tube over, this one. This is the IF amplifier, 12SK7. And I'm taking a look, 12SK7, yep. Four to the corner here to the detector tube, 12SQ7, and that's what it is. And then the last tube is the output tube, which I pulled out. That's what you're supposed to do with an output tube, isn't it? 50L6 is what it says on it, and here it says 50L6. So right tubes in the right place. Radio not working, must be from a dead tube. So it's tube testing time to find a dead tube. Okay, before I plug it in, let's just double check the settings here. 50L6, 50 volts on filament, JR heater settings, 5347 with a 0, 5347, 0, 30 on the bias control, 90 on the make the meter say what you want it to say control, B4, press B4, okay, here we go. Pretty quick. Now the most likely tubes to be defective, I think, are this tube, the output tube, and the rectifier tube. Well, I can see the heater coming on now, so it's not this tube with the open heater. Okay, we'll check for shorts here. I'm watching this light. If it flashes, that's fine. It's when it stays on that we're in trouble. Before we expect this, the reject point is basically 4100 on the 6000 scale. 4100, so anything below this, and she's a scrapper, and a like new tube would be 6500, which would actually be off the end of the scale. So it's right in the time to replace it range. But that means it's functioning. So no need to replace it. Now, if we're back in the 1940s, the company fixing this radio would have just sold a tube, thanks to that tube tester. Okay, we'll pull out the rectifier. We'll try this one next. And this was a 35Z5. Okay, I'll set up the tube tester for that. Give it a go. Okay, this tube's got something unusual going on with it. Let me just switch on an additional microphone here. So you can hear me just a wee bit better, I hope. 35Z5, first test is a ballast. This tube has, I guess, a resistive element in it. JR 0537 05370. None of the other settings matter. We should find a short all the way across. Not when we do this. Just waiting to see if it's gonna. Well, maybe it won't warm up on this setting. The heater's set to ballast here, so I think that's not the case. No heater. Okay, let's look for a short on every setting. Ooh, that's in between. Wait a minute. Number 2 has no short on 2. And so exactly what that means, I don't know, but it suggests a problem because it's a short on 1, 2, 3, 4, and 5. Okay, let me take this off here. Let's just see what happens. We'll do the others two tests. That was the ballast test. Now we'll do the actual test. JR0507 0507 0060 P3 for the rectifier section. Now this should, the tube should glow on this. 35? Yeah. See what happens. Yeah. Meters come on. Okay, we'll look for shorts. Nothing. Now, if this is a rectifier, we push the rectifier test button that's here, and all it's got to do is where? I use so many tube testers. So this one says diodes okay here. Maybe it's just English, and let's push the button to see what happens. Rectifier. Wow. So what do we got here? Let's put this on English. Let's push it again. Okay, so it's in the good. So I'm curious about that ballast deal. What is going on with that? 35 Z5. Let's see if we can find something more out about it. Is that 35 Z5? There's a center tapped heater ballast. Well, I don't see anything in the diagram here that suggests anything. I don't know. Well, for now we'll assume it's good. It can't be the cause of the lack of heatering in the radio. Okay, so the two tubes that work the hardest appear to be in functional shape. We'll just keep going through these signal tubes now. 12SA7. So I'll get set up for that. Okay, 12SA7 is a two tubes in one. It's an oscillator and an amplifier. We're going to do the amplifier first. 12.6 JR73465. 73465. 21. 34. Here we go. Okay, we'll do the short test. So when this flashes, that tells me the heater is probably operating and the tube is probably not open. So this should be 470. 470 is way down here. That's the reject point. The better tube is up around 750. Not very high on the meter. Here we go. Well, there you are. So it's weak. It's at 600 on that scale. It's supposed to be 750. Another tube sold back in the day. Okay, now we're going to do the next section. This tube tester, you can change these as long as you don't push the test button with the tube in place. 5346 with a 7. 5346 with a 7. 21. Yep. 34. Same as before. Oscillator section. Press P4. Same numbers. So once again, it's got to be above 470, way down here. Oh, it's above. And a good tube would be 750. 750 is about there. Ah. Okay, well this is not stopping the radio from operating either. So we'll just go on to the next tube. one of these should have an open heater, or there's something else going on. So now we've got the 12 SK7 here. I'll set the tube tester up for that. Okay, 12 SK7, 12.6 JR 4765 with a 3. 47653. 22, 72. We're good. Okay, are you the tube? Has reached its end. Pretty dirty on the top. Okay, short test. Notice the light is not flashing. Oh, saw a little flash, a little tiny flash. My guess is if we push the test button, it's not going to go anywhere. 1200 is what I would expect. This will be up around here. It's going nowhere. No evidence of the heater. I'm looking inside the tube. This is our bad guy right here. Rogers Majestic. Not so majestic anymore. 1928, 1946. So this is probably around 40s. This radio we're working on is probably from the late 40s. That was my guess. But this tube, I think, has met his end. Okay, we have one more tube to test, so we might as well do it. Because, well, it's not very likely two tubes would fail in this radio, because when one fails, when heater fails, the other tubes stop operating, so they can't continue to wear out. 12 SQ7. Okay, I'll leave the camera running here. This will be quick. 12 SQ7. JX. Okay, that sets the heater. 1603 with a 2. 1603 2 0 and 51. 0 on the bias. That's odd. 51 English. Now this English control only matters if you set this to English. Otherwise, and then you're reading these words, replace or good. Otherwise, I usually keep it on the actual scale and use the numbers. Should amount to pretty much the same thing. So we're doing the triode section. This is the detector tube. The triode section is basically the audio preamp in the radio. 630, so just up above here. Oh, let's plug him in. Plug the guy in. So I saw the pilot light flicker a bit, so that kind of suggests the heater's going. I can see the glow already. So this guy is does not have an open heater. Okay, we'll do the short test. Nothing staying on. 630 again is right about here. Push the button. It's okay. Might as well do the other half. These are diodes. So 05036. 05036. Some tube testers you cannot change the settings when the tube is plugged in. 0 and 0. P1 diode number 1. P1 diode number 1. So for diodes to be okay, this has to rise up above this mark here. You can't read it perhaps, but it says diode's okay with an arrow pointing this way. So it should pass up here. Let's try that again. Diode. Ooh, it's nowhere near. Triode seemed okay. Diode not so good. We'll try the other diode now. 0403. So I just changed the 0 of this one. This 5 becomes a 4. 04036. 00 P1 again. And again, it's got to come up above here. Both low. So well, it's a working tube, but very weak on the diodes. How that would affect the operation of the radio, I think it would cause low output, I think. So now the thing about a radio with low output is it's easy to compensate by simply turning up the volume. So it's a little hard to know the output is low, because you're just going to tend to turn up the volume a little higher. Okay, so we need another one of these guys, a 12 SK7. Okay, we're going to dig one out and give it a shot. Okay, so I'm going to use this tube, 12 SK7, but this one caught my attention in my box of tubes here, because it looks like this. They look the same, or similar. But look who made this. What brand is on it? Can you read that? Firestone. Air Chief, USA. Firestone? Wait a minute. Didn't Firestone make tires? So here's the story I heard about this. That the tire makers realized people were bringing their cars to garages to have the tires changed. And then they're sitting in the waiting room for, you know, half an hour, something like that, while their car gets attended to. Just sitting there looking around. And what do they see? They see radios for sale by Firestone. The tube manufacturers realized they had a captured audience sitting in waiting rooms and they could sell stuff to them. And they decided to sell radios. Now, it doesn't mean that they set up manufacturing factories and built radios. They just hire one of the radio manufacturers to make a radio for them that they could brand. And I guess they were doing the same thing with tubes, because after all, what do you want in your Firestone radio? You want Firestone tubes, of course. But these were probably made by just a regular tube manufacturer. I'm looking for some hint. So you have some letters here, V2K. Probably if we did enough research, we'd find out that this not only indicates who manufactured it, but even the factory they made it in. But I'm not going to use this one. I'm going to use this one. The other thing is, this is a glass tube. It's a metal tube. Would that make any difference? I don't think so. This one looks great. Okay, I'm going to give it a test. 12 SK7. Let's just keep it rolling. Keep it rolling. Keep it rolling. 12 SK, because it's fairly quick here. 12 SK7 JR. I want that to be correct for sure. In this tube tester, they've built this for speed. And if you're a repair guy, you're trying to get out of the guy's house as quick as possible. So one of the things they did with this tube tester is they isolated the settings for the filament. Here they are here. And once you set these two, you can throw the tube in, as long as this is set also, while you work on the rest of the settings. So the tube is heating up. Now that's efficiency. 4765. 4765.3. Already no higher voltages or signals are applied to the tube until you push the test button. And by the way, these tubes are not operated in this tube tester and most tube testers the way they're operated in a radio. This is not trying to mimic a radio. This is designed to determine a few factors, and it uses surprisingly rough signals, I can put it that way, to do it, to measure the GM and that. So I think it was a patented circuit. A patented circuit. 12 SK7. Just lost track of what I was doing here. Let's just make sure. 47653. 47653. 22. 72. P4. 1200. So we're on the 3000 scale, 1200, got to get up about here. Okay, do the shorts. Okay, not flashing very much. It doesn't really mean too much. P4 up to here. It's, oh, there's an effect going on there. Can you see the needle is dropping? The pointer is dropping. So it came up right close to 12 and then just fell back as I held the button. That's not a good sign for this tube. Actually, not a good one. So these tubes I have gone through, tested them all to make sure they work. You see, this one is unlabeled. So this is a recent one I just threw in my box with no label. I'll show you what a labeled one looks like. Tube number 16. So I have a record of all these tubes and what, in some cases the test result, but in most cases I just tested these enough to know that they function. So 12 SK7. So I don't have piles of dead tubes in my tube collection. Okay, focus here, Jim. 12 SK7. Give it a moment to warm up. So that means this tube is really weak. I'm trying to decide whether I should throw it out. I don't like throwing stuff out, especially stuff like that. Sometimes if I test a tube bad, I'll put it in another tube tester and test it there too, just to convince myself before I throw it away. Okay, shorts, get bigger flashes here. 1200, right to there. This one's exhibiting the same trait. It's falling off, falling back to 1200. Not really good too, but let's use this one for now, because all we're doing is testing the radio basically. So put this guy in here. That takes care of the tube with the open heater. Put Mr. Firestone back in here. This guy has to go away. I don't want him to get mixed up in my stuff, and this one I can't decide what to do with it. So, throwing away a tube. Oh, I actually have a box full. Oops, sorry about that. I actually have sorry about that. I actually have a box full of dead tubes that I just can't put in the garbage. Maybe I made a mistake and one of them's good. I mean, we're talking hundreds of tubes here. My failure rate on buying, say, loose tubes from people, hey, I got a box of loose tubes, do you want it? Failure rate on those is 30%, maybe a little higher at times. I'm also going to put this up on here so I can spin it around. Leave the antenna all coiled up. Okay, what do you do now? It's a little more serious this time because I'm pretty sure it's going to try to operate. So I'm going to flip the radio off, check that out, make sure nothing's happening. The switch is off. 112 volts. We are now going to switch it on. Volume down. There we go. Now, expect these lights to come on. This one, come on. Well, the heaters have a rush current when they're cold. Heaters heat up in a matter of a few seconds. That current will drop, the light will drop. Then we'll sit here for a while waiting for the rectifier tube to develop high voltage. When it does, the other tubes will start conducting, and then the current draw on the radio will go up. The bulb should get a little brighter. That's what we're expecting. What do we get? Very bright, very, very bright. Now this is a small wattage bulb. That's really, really it's slowly going down. So what I'm going to do, we're at 50 volt supply here. I'm going to screw in this other light bulb. I'm going to increase the, drop this resistance if you like. Increase the supply. Oh my God, didn't that scare you? It scared the heck out of me. What did I do? What did I knock over? I'm not sure. That was a light bulb falling somewhere. I have a couple spare light bulbs back there. It must have fell over. Scared enough out of me I stopped paying attention. Okay, what do I see? Filaments lighting, light bulbs on. The result is about almost 100 volts. That should be enough to make some noise. Yeah, awfully dirty. So a couple things are happening there. As I'm rotating the volume control, all of that scratchy sound means the slider inside is making very, very poor contact. Occasionally it made good contact, and what came out of the radio was a big hum. At other times, it seemed to make a small hum. I don't know if you noticed it. Kind of more of a buzzy sort of hum, and that's the contact being completely out of contact inside the volume control. And it becomes like a antenna. And what can it receive? Hums. It can't receive any radio or anything like that, but it can receive hums. It's very sensitive, right? It's heading for the audio amplifier, which is going to boost the little hum into a nice hum coming out of that speaker. So what's this tell us? It tells us that capacitor we saw in the filter is probably junk. But first, before I conclude that, I'm going to clean this control. We're going to run this test again. You can get surprising results from doing this. See if I can find my... Hey! Who took my cleaning stuff away? What's happened to it? Spot. Okay, a little shot of the good stuff. Now the set is off. So I'm going to spray it into the volume control just past these terminals because there's an opening that goes right in. And tip the radio back a little bit more if I can. So gravity will help me out with this. Just a little dab will do it. Now probably the radio's just gonna hum like a son of a gun. Okay, volume's turned down. Power back on through the dim lights. Two, going down now as the tubes begin to operate. 100. What do we get? Well, it's not humming that bad. And I hear a radio. How do you like that? Watching the string wrapping around here. Feels funny. It's wrapping up on that. Let's put it over here. Corrosion there. You get about halfway and the string starts doubling over inside the controller. Let's just keep going. So the string popping back. Now it picks up noises pretty good, but what about a station? Uh-oh. Just doesn't want to go. So this feels really stiff. This doesn't. This feels really stiff. Okay, next task is to unstiffen the capacitor there. So for that, I'm going to use the other magic elixir. WD-40. So there's some bearings and some contacts in the capacitor like this. A little hard to see in this radio with this diffuser on here. It's very odd. What's the you see there's the clip here, the light is on. They originally fit inside this kind of clip. And it looks like somebody put in a different style of clip to get a different style of light bulb. I don't know, that's very odd how that's been done. Okay, not to worry about that though. Now we are busy lubricating the tuning capacitor here. So there's a few places to get it. You can imagine there's a shaft going through and it's supported at either end. So we want to do the either ends. Just a little dab. Okay, a little dab's easier said than done. Yeah, that's a big dab. The front areas is probably where the restriction is because there's a, I think there's a shaft through a sleeve here. The back. Get right down inside. Let's go this way. There's usually ball bearings involved in this one. Okay, a little bit from the front. Is that just air? No, not just air. Get a little gravity helping out with that. Yeah, this is really stiff. This can't be. No, this is not stiff. I've got pulleys here, but these usually aren't causing significant drag. Wow. The string is fairly tense. Not loosening up very much. Okay, so that was the outside. I'm going to try to do this on the inside side of that. It's very tight in this radio. Let me get my mega light here. What I don't like about these spray cans is when you squeeze the spray top, it moves the it moves the tip around. Wacko. That's a goodly amount. Not coming loose. Still very tight. Okay, so we're going to do this now. This is a shaft and a sleeve arrangement. Yeah, sticking out here. This may be the problem. From the back. Not smoothed it out nicely. Still pretty tough. And slipping. Slipping. Very tight. It feels like it's getting more difficult as I turn it. Hey, what's going on here? It feels a little better than it did, but still very, very tight. It feels like it's getting tighter as I go. And it's probably because it's bunging up in here. Can't imagine these are. The string is pulling on these so tight. Kind of put a little bit on here. Try not to get it on the string. It's just a culmination of all kinds of different spots, and that was a little much. Oh, that made a difference. So if the back pressure, if we can call it that, from various drags on the string is great enough, then this isn't strong enough to overcome it, and you get slippage. So that's why you got to lubricate that stuff. You hear the ping sound? That's the string here not operating quite the way it should. Go back and forth. That sound right there. Getting better. So in here, it should be a nice shiny polished surface for the string to slide on when it needs to. That right there. And you shouldn't hear it or feel it. See, instead of making this so long that the string can travel all the way it wants, up and down, it can travel far enough that it starts dismounting from things. So they make it smaller, and when they make it a scoop shape, so the string tries to climb up the edges here. It can't, and instead it slides back towards the center. I don't know if you just saw it do that, but it just slid a long ways. But if the metal in here is dirty and not polished, you can't do that. Going back and forth a few times helps that out. Yeah, that's not bad. Okay, so we can tune right across now. I figure the string's going to break in a moment. Old string like this. Fair bit of... What's that? Is that a G? Let's play it again. Let's play it again. This time I'm going to clip on. I'm not going to use this wire. I'm going to clip on basically an outdoor antenna. That should help it out. I'm just putting on one lead from the antenna. I'm not putting on the other. I'm doing that for fun. Okay, we start with the volume down, but the power on. Oh, but not plugged in. Plug in. Oop. Just using the dim bulbs because I'm a scaredy cat. Can't any of my cats hear that? No. Okay. Give it a full Monty. Okay, with a nice antenna, what can you get? No idea where I'm tuned, but the middle of the band, so somewhere in here is a French station. No. Okay, so especially this sound here, these are all sounds I hear every time I operate an AM radio in my shop here. That's a sports channel, that's 590, and the reception is very good. It's really very good. Another station there. Unusual to pick up.
I'm not going back to that, but
so as radios go, it's working quite well. So we got another station just up here. No. Thought I heard something there. I like to use the French station as a good judge of the radio's ability to receive. So it's not picking up the French station. It is just on a piece of wire going outside, working pretty well. What more should I do with this radio? I mean, I could do all the capacitors, I could do all that stuff, but it doesn't seem to be asking for it. It's largely original under there. Now, what about the hum? There's no hum. Now, that hum is being received. Let's go back to the station and just listen to be sure.
I think that is jump one for any players, because one of the reasons that players in general in sports have been so guarded about, you think back a couple years ago, this whole debate about performance data, real-time in-game data, who controls it, how does it get out? I mean, one of the reasons that players have been so interested in controlling the, I don't know if you call it biomedical data, whatever, because that's going to help determine odds. You know, at some point, you know, we talked about slow heartbeat. Guy's got a real slow heartbeat. That's going to factor into the odds if he's standing at the free throw line. Like this is where all this is going. And you know, the late Kevin Towers, God bless him. I don't even know. This was amazing. It was just an amazing piss up at a winter meetings one time. I don't know how many people were out, but it was just amazing. Kevin Towers, general manager at the time.
Okay, remove this antenna because I'm going to check for chassis voltage, and I can't do it with it plugged into my bench supply. So I'm going to plug the radio straight into a regular outlet, and at that point the chassis could have 120 volts on it. I don't know. That's what I want to find out. Don't fall over. So I'm going to plug them in. And grab my voltmeter. Here it is. Dial up AC volts. Stick this one on a grounded thing. Here we are, grounded thing. Grounded in terms of the regular hydro system. What's on the chassis? Yeehaw! The whole shebang is there. Woo! That would be unpleasant. Now, I'm using a cheater cord here to plug it in. It's polarized, so I can't unpolarize it. What I'm going to do is I'm going to reverse the leads or the clip to the radio back here. So this is a danger radio. It's a danger radio for sure. Is it dangerous just because it is? Or is it dangerous because something has gone wrong inside? We need to consult the schematic, figure out how they wired this. As soon as you see a radio with 5 or 6 tubes in it, 35 is the typical number. And they have numbers like 30, 35, 50. You know that this could be a dangerous radio. Okay, so I'm going to plug it back in. I might be able to demonstrate one of the interesting dangers here. Nice bright light. Okay, back on the ground and on the chassis. And we see 0. Well, as long as I plug it in this way. Oh, son of a gun. Holy jeez. Peanut, you scared the. I'm gonna have to go shake my leg here to shake out what's in my pants now. That just freaked me right out. Okay, back on here. You see 0. Hey, it's safe. Is it? Let's turn it off. Now I am ungrounded here. I'm standing with. I'm not even going to touch the chassis because my life is too valuable for that. So I'm going to turn the radio off. I'm going to plug it back in the same way. It can only go in one way. Now it's turned off. What do we get when we measure it? Yeah, Peanut. Boy, you're pretty aggressive this morning. What do we get now? You see the danger of these radios? You see. Now, could this light a light bulb? Is it that kind of thing? Or is it a high resistance contact? Hey, buddy. Come on. What, you want some company? Peanut. Peanut. Yeah, I don't know. It could be food. Could be you want some lap time. I don't know what to think. So that's the thing about these radios, is you think you've made them safe because you figured it out with the switch on or the switch off. And when you turn the switch the other way, presto, the danger's back. So this is not as simple a matter as some might think. Oh my gosh. I'm going to stop for now and go and mess around with my cat. I'm going to unplug this because it's a little worrisome. Just a little worrisome. But I do wear rubber-soled slippers. Oh my gosh, I got my sock foot on the floor here. But that's okay because I'm standing on a rubberized mat. Right? Yes. Okay, Peanut. He's just driving me nuts here. Here I come, Peanut. Okay? Oh.